Welcome to the Salmon Runs YouTube. Enjoy the video.
You start by positioning and validating both gears. Open each component, check module, tooth count, and pitch. This ensures correct meshing. Move the gear bodies so their centers sit at the calculated center distance. Use construction lines and the measure tool for precision. Once done, make sure components are separate bodies and their rotation axes are aligned. This prevents interference during motion studies. Now save a version. Small mistakes are easier to fix when you can revert. Now define the relationship between the two gears using joints. Select Assemble right arrow joint, pick the revolute type for each gear, align the joint origin to each gear axis. Next, add a gear relationship. Pick both joints and set the ratio using tooth counts, for example 20/40. This enforces correct rotational motion. Why? Because the ratio locks angular velocities so teeth track correctly. Then enable joint limits and run a motion study to inspect engagement and catch any early interference. Finish by validating and finalizing the mesh. Run the interference and contact analyzes to find overlaps. If you see binding, slightly adjust center distance or add a 0. 1 mm clearance and retest. Make sure face widths and shaft alignments match. Misalignment causes edge binding even if ratios are correct. Once clean, bake the joints or export the assembly for animation. One troubleshooting tip: if motion skips, recheck the ratio input. An off by 1 in tooth count is the usual culprit.
Thanks for watching. Consider subscribing if we helped you.